Good morning all. Today's class is about gear trains. Sometimes two or more gears are made to mesh with each other to transmit power from one shaft to another. Such a combination is called gear train or train of toothed wheels. Here the first gear is known as the driver gear, and the power from this particular shaft transmitted to this particular shaft. Here the fourth gear is known as the driven gear or the follower, and the first gear is known as driver gear, and the last one is known as the driven gear or the follower gear. We can transfer or transmit power from the first shaft to the last one by using two or more gears mesh with each other. Then that particular combination, such a combination is known as gear train or train of toothed wheels. Okay, here this figure, this first figure is the front view of the gear train, and this one top view of the gear train. Okay, then the types of gear train. There are four main types of gear trains. First one simple gear train, second one compound gear train, third one reverted gear train, then the last one epicyclic gear train. Then in simple gear train, here we can see three different pictures. These three pictures, all of them represents simple gear train. In the first figure or figure A, there is one driver gear and one driven gear, or there is one driver gear and one follower. Here driver rotating in clockwise direction, then the driven or follower gear rotating in the anti-clockwise direction. And in the second figure, figure B, in the second figure, the driver, in between the driver and the driven or the follower gear, there is an intermediate gear, gear 2, intermediate gear is there. Then by using three different gears, we can transmit power from this particular shaft to this particular shaft. Here one intermediate gear is there in the case of the second simple gear train, and in the third case there is a driver and there is a follower, but two intermediate gears are there. First one driver rotating in the clockwise direction, then intermediate gear 2 rotating in the anti-clockwise direction, then the third gear rotating in the clockwise direction, then the last one, the driven or follower, final gear rotating in the anti-clockwise direction. And we know that whenever one gear or driver or follower gear rotating in the clockwise or anti-clockwise direction, then the gear which is mating with that particular gear must rotate in the opposite direction. If driver gear is in rotating in clockwise direction, then immediate gear nearer to this particular driver gear must rotate in the anti-clockwise direction. And these three figures, figure A, B and C, three figures, all of them represent simple gear train. And when there is only one gear on each shaft as shown in figure, it is known as a simple gear train. The gears are represented by their pitch circles. When we examine these three simple gear trains, we can see that each shaft, here this is the shaft, and each shaft carries only one gear. This particular shaft carries only one gear, and this particular shaft carries only one gear. Here again in this particular shaft. In this case, this particular shaft carries only one gear. Similarly, all the shafts shown in this particular figure carries only one gears each. So such a type of gear trains are known as simple gear trains. Okay, and here n1 is equal to speed of the gear. N1 is equal to speed of the gear 1 or driver in RPM, is speed of the gear of this particular driver, and n2 is the speed of the gear of this particular gear, follower gear. Then T1 is equal to number of teeth on gear 1. T1 is equal to number of gear on this driver, and T2 is the number of gear on this driven gear. Then speed ratio is equal to n1 by n2. Speed ratio is equal to n1 by n2, and we know that this n1 is inversely proportional to the number of teeth. If number of teeth increases, then the number of rotations decreases. That is the case. So RPM, or number of rotations per minute or number of rotations per second, RPS, is always inversely proportional to number of teeth. Then speed ratio is equal to n1 by n2, the speed of first gear, driver gear, divided by speed of the follower gear, n1 by n2. Then that must be equal to t2 by t1. And this is the case of speed ratio. Here in the case of speed ratio, speed ratio is equal to n1 by n2, that is equal to t2 by t1. And train value is just inverse of this one, n2 by n1. N2 by n1 is the train value, and that's equal to t1 by t2. This one train value, and this one represents the speed ratio. But speed ratio is equal to speed or RPM of the driver divided by speed of the follower. Speed of the driver divided by speed of the follower, n1 by n2. That is the speed ratio. Whereas n2 by n1, speed of the follower divided by speed of the driver, is equal to the train value. Okay. Then speed ratio is this one, and train value is this one, n2 by n1. Okay. Next, if there are three gears meshing with each other, first one driver, second one intermediate gear, and third one driven or follower, then n1 by n2 is equal to t2 by t1. n1 by n2 is equal to t2 by t1. If there are three gears, first one driver gear, second one intermediate gear, third one driven or follower, then n1 by n2 is equal to t2 by t1. Similarly, n2 by n3 is equal to t3 by t2. n2 by n3 is equal to t3 by t2. Then we can multiply equation number 1 and equation number 2. Then n1 by n2 into n2 by n3 is equal to t2 by t1 into t3 by t2. That's equal to n1 by n2 into n2 by n3 is equal to t2 by t1 into t3 by t2, or n1 by n3. We can cancel n1 and n2 and n2. Then n1 by n3 is equal to t2. We can cancel this t2. Then t3 by t1. Then speed ratio n1 by n2, speed of the driver divided by speed of the here n1 is the speed of the driver and n3 is the speed of the follower, then that's equal to t3 by t1. t3 by t1 means number of teeth on the driver. t3 by t1 is equal to number of teeth on the driven or follower divided by number of teeth on the driver. Number of teeth on the driver, t1 is equal to number of teeth on the driver, t3 is equal to number of teeth on the follower. Then train value is just opposite to this speed ratio, then that's equal to number of teeth on driver divided by number of teeth on the driven or follower. That is the case of a simple gear train having three gears. Okay, next, compound gear train. Compound gear train. When there are more than one gear on a shaft, as shown in figure, it is called a compound gear train. When we examine this particular gear arrangement, we can see that on this particular shaft, there are two gears. On this particular shaft, two gears are mounted on this particular shaft, and again on this particular shaft, there again two gears are there. Gears 4 and 5 are there. On this particular shaft, gears 2 and 3 mounted on this particular shaft. Such a type of gear trains are known as a compound gear train. Such a type of gear trains are known as a compound gear train. We know that the number of rotations for this particular gear 2, must be equal to the speed of the gear 3. Similarly, speed of gear 4 must be equal to speed of gear 5, because they are mounted on the same shaft. Such kind of gear arrangement is known as a compound gear train. In compound gear train, is shown in figure, n1 is equal to speed of the driving gear 1, n1 speed of the driver, then t1 is the number of teeth on the driving gear, then n2, n3, n4, n5 and n6 are the speed of the respective gears in RPM. Similarly, t2, t3, t4, t5, t6 etc. number of teeth on respective gears. Here we know that n1 by n2, n1 by n2 is equal to t2 by t1. n1 by n2 is equal to t2 by t1. Similarly, n3 by n4 is equal to t4 by t3. Similarly, n5 by n6 is equal to t5 by t6. n5 by n6 is equal to t6 by t5. Then we can multiply these three equations. Then n1 by n2 into n3 by n4 into n5 by n6 is equal to t2 by t1 into t4 by t3 into t6 by t5. Or the number of rotation n2 must be equal to n3, n4 must be equal to n5, because they are mounted on the same shaft. Then we can cancel this n2 and n3, similarly n4 and n5. Then we will get n1 by n6 is equal to t2 into t4 into t6 divided by t1 into t3 into t5. By closely examining this particular figure, we know that t2 into t4 into t6, t2 is a follower, t4 again a follower, t6 again a follower. Then t2 into t4 into t6 is equal to product of number of teeth on the follower gears divided by t1 a driver, t3 again a driver, t5 again a driver. Then T1 into T3 into T5 is equal to product of number of teeth on the driving gears. This one driven gears or follower gears. Then N1 by N6, N1 by N6 is known as the speed ratio of the compound gear train is equal to product of number of teeth on the driven gear is equal to product of number of teeth on the driven gear or follower gears divided by product of number of teeth on the driving gears. That is the speed ratio of the compound gear train. Then speed ratio is equal to speed of the first driver divided by speed of the last driven or follower. Speed ratio of the compound gear train, that is equal to product of number of teeth on the drivens divided by product of number of teeth on the drivers. Train value just opposite to this one. Product of number of teeth on the drivers divided by product of number of teeth on the drivens. This is the speed ratio and the train value of the compound gear train. Okay, thank you all.